Welcome to the chemistry magic show. Welcome to the chemistry magic show.
So welcome everyone to our annual chemistry magic show. We just started out with, well, I'm going to let Casey Pinland tell you what we just did.
So on the sign we painted with an acid-base indicator phenolphthalein. And phenolphthalein is colorless in acidic and neutral solutions. But in basic solutions, it turns pink. And so you'll see that the color is fading rather quickly, and that's for two reasons. One, the ammonia is evaporating into the air, so it's becoming neutral, and also carbon dioxide in the air is neutralizing it. Therefore, it goes back to colorless.
Can you get the color back, you think, Casey?
I don't know, let's try. Yep. Woo! You sure can, Dr. Jones.
So welcome everyone. We are so pleased to have a great crowd, an enthusiastic crowd it sounds like already, for this, our annual chemistry magic show. This has become a tradition. We've been doing this now for more than 20 years, and we really do enjoy having this opportunity to share some chemistry magic with the community. I see several of our students, and I see some of our faculty, and I see youngsters, and I see pals, and I see just a whole bunch of people. We want to thank you so much for coming out. The show tonight, or the show that we have, would not be possible, or the refreshments certainly would not be possible without the Office of the Vice President of Academic Affairs. So if you could give a round of applause to Dr. Novotny and to Dodi Day. They're the ones who made it possible for us to have these refreshments. Also, we need to thank Facility Services for helping us get this all set up with the tables and the chairs and everything. So give them a round of applause as well. And give yourselves a round of applause, because we couldn't do this without audience members to share it with us. All right, so we have a few ground rules here. One of them is that we want to be safe while we do this. And we want you to be safe while we do this too. So we have safety goggles that we'll all be wearing as we're doing these tricks. Did you happen to see? Wait. Here's all our magicians. Does it look like they have safety goggles? Yes? Yes? Looks to me like they have safety goggles. So let me just see if I can get you to tell the difference between how I'm wearing them and how they are wearing them. You guys notice any differences? Yes. What do you see out there, pal? Are these goggles covering their eyes? Oh, no. Students, put those goggles over your eyes. Oh, that's right. So, hang on, don't go yet. So we need to do just a little practice here. If any of these folks, if any of these excellent students come out without their eye protection, what do you think we should do? Ooh, okay. So I think. Okay, here they are. No, they're going to be safe now. So what do we do now? So when they come out, if they don't have their goggles on, you just holler at them so that they will put their goggles on. Now the other practice that we need to do is to make sure that you let us know when you like a trick. So if you like a trick, then how about woohoo? You guys do that? Let's try it. If you'd rather say ooh, you do that too. Just let us know in your voice that you like what we're doing. Okay, so one last bit of housekeeping before we start the magic. Before we start the magic show, but before we continue, and that is a reminder that after the show itself is over here at Richardson Hall, we do have hands-on activities for people on the third floor of Porter Hall, rooms 324 and 320. Though there are balloons that will guide you up the stairs, or if you need to take the elevator, you can take the elevator to the third floor, and then just continue down the hallway. The first room you'll come to is room 324, and then room 320 after that. So we have 3 different hands-on activities for you to participate in. And these are suitable for children of all ages, even an old child like this. So I'll give you another reminder about that in the near future, at the end of the show. Well, is Bryce Turner somewhere out here? Ooh, Bryce!
Are you on? All right, how are you guys doing today? So, since we're kind of still at the start of our show, I thought I'd start, Dr. Jones, by invoking some of the spirits of elements.
Ooh, I like that idea.
So they can watch over our show. So, what I'm going to have here is the spirit of sodium. And spirit of strontium. And last, spirit copper. Strontium. Yes. Okay. Now, we could trim the lights down a little bit.
One of the differences between a magic show that you might go see in Las Vegas or Denver or something else, is that those magicians will probably not tell you how their tricks work. But you notice that when Casey came out and did her trick, she told you exactly how the trick worked. So, Bryce, can you tell us what happened there?
So these solutions that I poured were a saturated solution of these specific elements. And when you put fire to it, it adds some energy to these elements. And some of that energy comes off in the form of the flame. And so each element gives you a specific color. As we saw, strontium had that nice kind of red-purple color. The sodium had a good yellow color. And the copper had that, blue-green, nice turquoise color. So.
So we've seen some colors now. Would you like to see some more colors?
Yeah!
Can we accommodate more colors? Good job, team. Keep these folks on their toes.
Cinnamon, all right. Is everyone enjoying the magic show so far? Yeah! So we need some way to pay for the magic show. We haven't figured that out yet. How can we pay for the magic show? What could we use? Money! What? Money! What kind of money? Oh! What kind of money? Real money. Money that are gold. Can we use gold? Yeah. Where can we find gold at? Underground. Rainbows. Pot of gold can use a rainbow. Well, let's try to make our own rainbow and see what happens. Okay, first off, we're going to start making it one color at a time. Let's start with purple.
Wow, that's really pretty, Rena.
Beautiful color.
What do you guys think? Is that a nice color?
All right, time to add some of the magic potion.
You guys see anything happening?
One last ingredient.
Did you see all the colors of the rainbow there? Oh yeah, very nice.
So do you think we found gold? Alright, so what happened during this experiment was we start off with the original solution, which contains the base universe indicator. Universe indicator is a mixture of indicators which change color as they go from the base base, causing color change. And then at the end, we added a stronger acid, the hydrochloric acid, to cause the final color change and make a rainbow.
Very nice. Oh, look, they learned their lesson. They've got their goggles on. Well, we've had some colors. We had some fire as well at the very beginning. What should we do next? What would you guys like to have next? What? Oh, explosions? Yeah, you think so? Oh, okay, hang on. Andrea, are you out there somewhere? Are you back behind this table? You know what? I think it was right here in the front row.
Oh, you know, one of my favorite parts about chemistry is explosions and fire. So today, what I'm going to show you is an explosive substance.
Well, it did in fact, and all you had to do was set a match to it.
No, I just had to light it on fire. And we all over the place.
So, Andrea, what happened? What was in the can up there?
Well, what I did before I came is I filled this can up with some methane gas. And then there's little holes on each side, and then there was a hole on the top that I could light the gas as it came out. When the oxygen from the air combines with the methane, it forms a combustion mixture. And so when enough air gets inside of the can, it makes an awesome explosion.
Excellent. So, since we're talking about forces of nature, explosions and things of that sort, let's bring out Josh.
Alright, how many of you guys do any recycling? Yes. Raise your hand. You guys recycle pop cans? No? Yeah. Okay. I'm going to show you guys a way to brush a pop can without using your feet and scuffing up your mom's floor and getting yelled at.
Moms, you wouldn't really do that, would you yell at somebody who was trying to be environmentally responsible and recycle aluminum? Oh, I understand that maybe one or two people would. So, Josh, it's going to be great for you to show us how to do that.
What happened is I started out by boiling some water in the can, and then the water as it boils produces steam, which forces all the air out, and then when I invert it into the ice water here, the vapor recondenses into water, and and creates a partial vacuum, and then the outside pressure, the atmospheric pressure, crushes the can.
Thank you, Josh. So now you know the trick. You're putting those cans in the Habitat for Humanity bins. You want to crush them first so that they don't take up as much space. There's a way to do it. So, you guys all had a chance to get out there and have a few cookies and things of that sort. Our magicians have been working pretty hard without really taking a break all afternoon. And so, I'm wondering if they're a little hungry. Bryce, are you hungry at all?
All right, how are you guys liking the magic show? Oh, good. So you guys may know, as I recall it, it's pretty common to try and find some ways to, save a little money. And so I was trying to think, what could I do to save some money? And I was thinking this while I was having the pickle that I have for lunch every day for $1. I was thinking, I wonder if that pickle could be a light bulb. What do you guys think? Yes. Yeah? All right. So let's try this out. All right. So,
Did he say a light bulb?
I did.
A light bulb? What do you need for a light bulb?
A pickle. Some electricity.
Oh, electricity.
Yeah. Just a little. Yeah. All right. So, to really test this out, why don't we turn the lights off and see if this can light it up. Okay. Let's see what happens. Once I get it plugged. What's happening? You guys hear it?
It looks like a light bulb. So what color did you see coming out of that pickle? Orange, yellow. Do you remember when this fine young man called in the spirits of chemistry? Yes. What colors did you see? Did you see an orange color? Yeah, so that orange color is the same orange color that you see here with the pickle.
All right.
Hey, it's almost time for Halloween, isn't it? Yeah, about another week, a week and a few days. Rachel, what do you have here?
he actually came from the dentist and got some dental work, so he's a little bit patched up. Okay. And we're going to see what he's going to help us with today. He's going to show us a little bit of chemistry magic. And we're going to get started.
So folks, you may, when we tell you, it may be a good idea to protect your ears.
Who thinks Frankenstein might give them a spook? So, since he's been to the dentist, he's a little bit thirsty, so we're going to give him just a little water.
Okay, everybody have your ears ready. Okay. Frankenstein.
So when it builds up inside the pumpkin, and I let it rain to it, it exploded. Whoa!
Alrighty, folks. It's hard to beat a excuse me. It's hard to beat a self-carving pumpkin like that one. But I think we have another enjoyable trick for you. Let's see, Andrea, can you come back out, please? Are you going to make a campfire for us, Andrea?
Well, not really, but I will make fire.
Okay.
And it'll be pretty cool called Home Fire. So it's pretty awesome just like that. But then we can make the fire even bigger. Isn't that awesome? It's so exciting.
So what happens if you turn it the other way, Andrea?
Oh, let's see. It rotated the other direction, Dr. Jones.
Oh, that's way cool. It is awesome. What happens if you don't have the screen on?
Well, it just kind of hangs out like that. Just burns. It doesn't really go that high. It's kind of boring. I like fires, but it's just kind of staying there, you know? Let's see. I wonder if I spin it harder. Do you think it'll work? Not really. I think it's time to put the fire out.
So what happened there, Andrea?
Well, you noticed when I was just looking at the screen, it just looked like a normal fire. It kind of had some motion to it, but it wasn't too great. And then when you put the screen, what happens is it creates an air tunnel, and as the air is swirling around and the screen is spinning, then it makes the flame spin up higher and higher, which is why it got so tall.
All right, thank you, Andrea. Whew, it's getting a little warm up here. I don't know about you guys out in the audience, but all this fire up here has made me pretty warm. But I think maybe we have something else besides fire at the moment. So let's see, Casey and
Casey, I'm a little confused here. What are you doing with the cinder block? I just don't know. Yeah? How cool is it? Okay, yeah.
You want to see it first and then you can decide whether or not
Yeah.
Okay, Bryce, just lay down on the ground.
what? This must be a cool trick.
Okay, Bryce, I'm going to put this on your tummy. Okay, stay
Whoa,
still.
what are you doing?
I'm going to show you a magic trick.
Okay.
Okay, don't move.
Okay. Ouch.
Okay, let me try again. Bryce,
I'm okay.
why did that hurt?
Well, because of Newton's first law, and this is a much heavier object than the hammer. So, to pour some heart into it didn't have enough to actually hurt me in any way. No. You don't get $1.
Well, can I show you another magic trick?
Yeah?
Okay, but this time I need $1.
Okay. what are you doing with my dollar there? Well, I mean, I'm
What's she doing with your dollar, Bryce?
I don't have a dollar.
I'm just gonna get it nice and wet, don't worry.
It's nice and wet. That's what she said, it was nice and
Seems
wet.
like I should worry about it.
No,
I'm a little worried.
Casey wouldn't do anything to your dollar.
No, I guess it's pretty much.
She's a good friend.
That's right.
Can I get the light?
What are you doing?
Don't worry, Bryce.
Casey, don't put my dollar!
Don't worry, Bryce.
Casey!
What happened?
Wow. Why did my dollar? Cool.
Well, Bryce, in this solution, there is 50% alcohol and 50% water. The water absorbed in the dollar, and the alcohol stayed on the surface and evaporated away, so only that was burned.
Wow! That's pretty cool, Dr. Joe. Great.
Wow. So apparently Bryce had money to burn, but didn't it burn? Didn't you see the flame? Yeah, I mean it was burning, but
Okay, so how many of you kids have pets? Me! What kind of pets do you have? A cat. Three cats, 2 rabbits, and a dog. Two rabbits. I have pets. And let me tell you what, brushing kids' teeth is not easy. Have you seen elephants' teeth? Are they big? Yeah? Yeah? Well, I have to make a special toothpaste just for my elephant. So, in order to make it, I first add a little bit of the cleaner. A little bit of whitener. I want it to be nice and clean and shiny. A little bit of magic ingredients.
oh, what's happening here?
And we have elephant toothpaste. Okay, so what happened during this experiment is a
Well, folks, it's been a few minutes since we had any sort of fire. Fire is always a good part of chemistry magic shows. So let's call Josh to come out here and see what we can do about more fire. Hey Josh, what does it say on your balloons here?
National Chemistry Week.
National Chemistry Week. So do you guys know that 2 days from now is a day that all chemists celebrate? It's called Mole Day. Mole Day, do you guys know what a mole is? What is a mole? It is a tiny furry little critter, but what is a chemistry mole? Who knows? What? Does anybody know? Let's see. It's a big number, right? Do you know how big the number is? No, it's bigger than 100. Did you guys hear that? 6.02 times 10 to the 23rd. What is Sunday? Who's the 23rd of what month? The 10th month. So Mole Day is always October 23rd, and that marks the beginning of National Chemistry Week. So we're here to celebrate National Chemistry Week. Can you get us started on this?
Okay, for this experiment, I need all of you in the audience to cover your ears.
Josh, I thought you were going to start us off with a bang here.
That's the idea, Dr. Jones. Let's see if I can do better.
Okay, we'll give you one more try.
Okay, cover your ears again.
Ooh, they said do it again, Josh. Can you do it again? Was that cool or what?
What's left of this balloon was just filled with oxygen, which by itself just basically pops. The red balloon that made that pretty neat flame had hydrogen in it. And then the third one that made the biggest boom was filled with a mixture of 2 parts hydrogen and 1 part oxygen, which you all know is water. So when the 2 parts combined, when the match lit it, they combined water and then exploded.
So folks, we're getting close to the end of the show. Hope you've enjoyed it. know that chemistry is really a pretty fun topic, nothing to be afraid of, well, unless you're afraid of explosions. But it's a really fun thing, and we want to thank you again for coming. I think we have maybe 2 more tricks to go. Rachel. Rachel, that's a pretty interesting device that you brought out onto the stage there. What is that?
It's one of the reasons why I love chemistry.
This has to be good because Rachel has loved chemistry for a long time. If this is good, then we need, oh yeah, there we go.
Are you guys having fun so far? Well, there's still more.
That's amazing, Rachel.
This just shows you how chemistry brings light to your life. Alright, so what happened here is that these 2 solutions mix to form a chemical reaction. And do you guys know those lights that you bring on Halloween, where you crack them open and they light up? Well, that reaction is chemiluminescence. It has so much energy that it's giving off a blue-colored light.
And it's cool, isn't it?
Very
Can you grab that pink? Oh yeah, it's not like a fire, right? It's nice cool light. Excellent. Thank you, Rachel. So we have one more trick, but before we do this trick, we'd like to ask the students to come back up on stage to get a round of applause for all the great work they've done. Well, let me give you the names of these folks. We have Rita Reyes, Andrea Turney, Rachel Redempton, Casey Penland. Bryce, where are you, buddy?
Bryce? Hello? Marco?
He's running downstairs. He's coming. Josh, where's Josh? Come on up on the stage. Everybody, give a good round of applause. So this is Josh Houston and Bryce Turner. I don't see where Bryce is. But at any rate, these folks worked really hard to put on this magic show for you. Let's tell them how appreciative we are with a big round of applause. Oh, here we go, excellent. Folks, it's going to require just a couple of minutes of setup to get this last one ready for you. Hey, Chris. So let me introduce you as some of our faculty, or all of our faculty are participating in this magic show. Chris Adams is our physical chemist. Renee Beaton is our analytical chemist. Christy Miller is our biochemist and the program coordinator for the chemistry program. And I'm Marty Jones. Chris. You know, it seems to me, if I remember correctly, and since I'm getting older, memory starts to go, but it seems to me that music has been a big part of our chemistry magic shows in the past.
Yeah, just about ever since I can remember. I mean, we've had some music at the end,
So,
I mean, some years ago we had.
you guys hear anything? Do you hear some music?
This sounds pretty familiar.
Ooh. Do you guys recognize this?
1812 Overture.
Let's get louder.
Oh yeah, I remember. What did we do with the...
I think we blew some.
Yeah, I think we blew up some balloons. Right, yeah, excellent. But then we've done some other things too, haven't we?
Yeah, I can remember a few.
What have we done before? What did we do with this one, Dr. Miller?
We had an acid-base reaction with the rainbow.
Oh yeah, the rainbow connection. And then, didn't we do something really special last year? What did we do last year?
I remember. Yeah. Somewhere over the rainbow, way up high. We did the Wizard of Oz.
that was really cool, don't you think? But you know, Chris, this year, I'm kind of thinking that we need something different.
What are you thinking?
Well, I'm thinking that it would really be nice to be able to see music. You know, we had a really good presentation, a faculty lecture on Wednesday night with Dr. Escalas from physics and Dr. Doyle from the music department. And they taught us about music being waves, energy that travels in waves.
Yeah, I recall that, yeah.
Do you think there's any way that we would be able to see music, not just listen to it?
I think with this setup here, we might be able to make something happen. I think we can do it.
You think so? Are you guys interested in seeing if we can see music? But you know, if we're going to see music, we have to have some music. You guys have any recommendations about music? What? We had a request for Rocket Man.
I think we have it.
Dude, let me see. This is a new thing for me, so.
What's our favorite?
Yes, it's on here. Let's see.
Let me go ahead and get this lit and see what happens. Nothing yet. Okay, we've got it hooked up now. Now, if you're right that the sound is waves, we should be able to see this dance as the sound waves pass through the tube. So let's see if it works. Okay. There it goes, look at the dance. You know, it'd be nice if we could get some rockets.
Is one of those enough, or do we need another rocket?
So what we have set up is a speaker at the end of this tube. And of course this is going to set up pressure waves in here. Where the pressure becomes highest, we see a high flame. Where the pressure that might help. So we set up pressure waves in this flame using this speaker, and where the pressure builds up, we get a larger flame. When it goes down, we actually get a smaller flame, and that explains why it starts moving with the music.
So we made the original bottle rocket over here. So we just used 2-liter bottles and we flushed them with oxygen and then we put methanol in, shook it up to get the methanol vapor, dumped out the liquid, and then just lit the end and flew down the wire.
So folks, that brings us to the end of this year's magic show. We want to thank you very much for coming. And again, thank our student presenters, thank all our faculty,
Adams State College. Great stories begin here.